So in the last video, we talked about internal energy, and we said internal energy is basically the total energy content in the system, in a body, and it comprises of both kinetic energy and potential energy. And kinetic energy is nothing but the thermal energy content in the system. And then the potential energy, it comprises of the other forms of energy like chemical energy, nuclear energy, magnetic energy, electrical energy. So basically the forms of energy that are associated with how the system is configured, how the atoms are arranged. So their interatomic and intermolecular forces of attraction and so on. So I also mentioned in an earlier video that the only way this internal energy can be changed is by virtue of either transfer of heat to and from the system, or by doing work on the system. Either the system does work on the surroundings, or the surroundings do work on the system. So these are the only two ways you can actually change the energy content or the internal energy of a system. So now let's look at these two concepts of heat and work in a little more detail here. So first, heat, the way heat is defined is heat is the thermal energy. Heat is the thermal energy. So this is the kinetic energy part of the internal energy. Remember that. So it is a thermal energy that can be transferred from an object at a higher temperature to an object at a lower temperature. So it's important to remember that this transfer of energy will depend only on the temperatures, the relative difference in the temperatures between the two bodies. It has nothing to do with how big or how small the bodies are, or how much the thermal energy content in each of these bodies is. So for example, if you take a small nail that is at a much higher temperature than let's say a big wooden box that you're going to put the nail into, and this big wooden box is a much bigger system, it has a much higher mass to it, but the heat will flow here only from the nail to the box. So that is an important point to remember. And as long as there is a temperature difference, there will be a transfer of heat, and when both the bodies are at the same temperature, the transfer of heat will stop. So another important thing to note here is that the energy transfer is always heat going from the hotter body to a colder body, but cold never travels from a colder body to a hotter body. Let's say, for example, you take a big block of ice and put it on your skin. Your skin feels cold, not because the cold is traveling from the ice to your body, but it's because your skin is at a higher temperature. So the heat actually travels from your skin to the block of ice, and hence your skin temperature drops and you feel cold. So I just jotted down those points here as notes. So just a simple notation: heat is denoted by Q in thermodynamics. So moving on, consider for example the energy stored in a fully charged battery. So let's say, okay, now this energy can be used primarily to perform work, like for example you have this hand electric fan where the electrical energy contained in a battery is used to perform mechanical work, that is rotating the blades of the fan. Or you could use the same batteries for lighting a electric bulb. So you can generate light and heat. There is no work done here. You're converting electrical energy into light and heat. So when the battery is fully discharged, in either cases, the total change in energy is the same. So it's always difficult to measure the absolute internal energy of a system or a body. So you always measure the delta, that is the difference in the internal energies between the initial state and the final state. So the initial state here in this case is a charged battery, and the final state is a discharged battery, and that is the delta E. So when the battery is fully discharged, in both cases the total energy change, the change in the internal energy is the same, but the fraction that is released as work and as heat varies differently. So in this case, most of the change in internal energy is because of the work done, and a little bit maybe the heat is also generated. So that's what is denoted by Q here. But in this case, the change in internal energy is completely due to transfer of thermal energy, and we denote it by Q. There's no work done here. But the important thing to note is the difference between the initial and the final states is the same. Whether the change was because of work done or because of heat generated, the difference between the initial and the final states is the same. So that's why internal energy is a state function here. We'll also see in the next video that work, on the other hand, is not a state function, but delta E here is a state function. So we can write here that delta E is equal to Q plus W. And this is the first big important relationship that you're going to learn in thermodynamics. So change in internal energy is equal to the heat produced plus work done. And we'll talk about the meaning of W here. Well, that's the work done by either by the system or by the surroundings in a little more detail in the next video.